All right, we've got another problem here that we're gonna try to figure out. So a container with the most water, you're given an integer, let's click this up a little. Given an integer of height of length of n. There are n vertical lines drawn to such a point that the ith line are I to 0, I height of I. You're given an integer array. There are n vertical lines, the length of n. Okay, so n vertical lines drawn that so the n points at the ith line, I is 0. So if there are 10 vertical lines drawn that such 2 are I 0, I height of I. Find the two lines that together form a container such that contains the most water. Return the maximum water that it can store. Notice that you may not slant the container. All right, so this boom, it could be basically any of those. So you want to find the first highest thing. So if you did that one, so this input is 1, 8, 6, okay. The output should be 49. 8 times 7. What is that 49? How do you calculate? Oh, because it's a 7 by 7 block. Is it 7 by 7? 1, 2, 3, 4, 5, 6, 7. And it's 7 high. Okay, so it's just those two. N is equal to the height. Okay. 2 is less than 10 to the 5. And the height is going to be between 0 and 10 to the 4. Okay. So, let's grab this. And what number is this? Okay. Directory for 11. Package. Area, height, which is a list of integers, and let's do this. We're going to call max area, and let's pass it 8, 6, 2, 5, 4, 8, 7. That's not the right, so it should be. Okay. And this is return. So, all right, so I get us up and running. That may not found. So basically, so let's do the just simple method first. So matrix, okay, best I guess I could store form, range, length of height, or B, and range of height minus A. Height equals okay. If height of B is less than if height of B is less than tallness. Those are heights. Size is if height of B is less than size equals height of B. Second. And then I can see width equals B minus A. So this might be 1. Result equals width times 6. If result is greater than this, all right, that worked pretty simple, but I feel like there's some optimizations we should be able to do. So is there any way I can discard certain results? If our height is 0, we can skip it. But I think we have an assertion that height is always going to be less than, it could be 0, but we can reverse order. And if I start the farthest, then that lets me discard the best size. So B is, let's flip this. So B equals if size is less than best size. So basically, we start from the end. If we've already worked with something taller, we can discard it. Size is less than is greater. Now I'm getting 0 from our result though, so that's broke something. Is less than. I got my result. So is that faster? I think it is, right? Because this should, if basically once I process this, this can be discarded. It's going to check this. If this is a 1, would it ever be possible to? Yeah, we call it good for now. There we go. We want reps more than we care about perfection. So I'll run this. Let's run the test cases. Any types or anything. Output, so 1.1, and it expects. So let's input that. So 1.1, so it should be that was the issue. Add this +1 that I didn't need because I am greater than I'm not greater than and equal to. Let's see if that fixed it. Okay. And we'll submit. Let's see if that is happy. Or if I broke something. It is quite. Too slow. So it might be working, but I need to be able to discard more cases. So what can I do? I've got... Let me make sure this is... Oh, it's not easy. It's nice, huh? Not executing wrong, really? So I got something wrong. So A can only get worse. So if I've got a high min A, the minimum if A is less than minimum, oh. Okay. But I should only consider things larger than it. It's larger, so it should be considered, but it turned out not to be large enough. Well, everything else can be just ditched. So that I do think seems true. But I've hit a high A. I don't need to consider anything smaller. B is like B. Hello? Where'd it go? I think min and b just have to cycle. See if that's any faster. I mean, basically all I did is rework when we can skip processing 8s. And let's see. It's happy. Let's see if it actually can get through the solution, if it's too slow. Did it take it? Time out. Got there 56 of them. Can I skip? So it's still, so when I got 20,000 items in here, it's still failing. So we can increment the width. It should really be as the width. Width is less than the length of height. So if ever because it's multiplying two numbers, what if I just take the average of 2 and discard anything that's below average? That would get rid of half of the inputs. Would it ever be that a small input wins? I guess it could be if you had a list of 1s and then a 100, 100 list of 1s, you might discard your 1, 1. So I want to figure out how to walk through this. So what could I do to help figure this out? I think it has something to do with the second thing. I can discard a whole lot of A's. Basically, I need to figure out width total equals width times height. what if I had two cursors that I advance as needed? Because yeah, that's what I do. So I start cursor B, and I just keep advancing cursor A until I get to a new high, and then I advance cursor B until I can beat it. And by changing one of those things, let's try that, because I think that we should be able to do O of n, right? Each thing has to be considered one time versus potentially two times. So let's get rid of all this. Cursor. A equals, sorry, cursor. B equals length, height, range of cursor. So equals cursor height. Oh, but I needed the minimum, so maybe that's something I'm missing. Do I need to consider things that are shorter than that, because it can deduct from that? So. Okay, just call y. Min y equal min height of cursor A. Height of x. Percent is greater than. So this gives me this, but I don't have the cursor behavior yet. So that just walks through to each of these. So So basically, if it got bigger, we are going to start incrementing B. If it didn't get bigger, we're going to keep advancing A. Does that work? I don't think that works. So what I want to have happen, so this one, it got bigger, so that's fine. Bigger. That's fine. That's smaller, so I don't want to do that one. Result. So if it was turned out to be taller though, let's see what our heads are. Try to use 2 pointers. Set one pointer to the left, one to the right. Always move the pointer that points to the lower line. Oh. I guess that makes sense because if you were pointing to a higher one, then it is the better of the 2 options. We discard the worst of the 2 options. Okay. So for length and height, let's go. Listen to them. Line. It's an 8. No. Height, cursor A. Oh, it's got to be ordered. if cursor height A, cursors were 0 and 8. 0, 1, 2, 3, 6, 7, 8. So that's right. But it decremented that. Oh. Well, if I do that, what is this? Let's see if that seems easier versus my simulating approach before. Pass the test cases. Beauty. All right. Do I feel pretty good about that? I do. The thing I was missing about that was the idea of multiple cursors that move in, and that critical piece of logic of you should decrement the smaller container, right? You can't improve your position by losing the smaller of the two options. But if you always keep the larger option, right, until you come along something better, then reducing width will be a potentially better option. All right, that's it for number 2.